Okay, picture this. An AI that helps decide which life-saving but super expensive drugs get funded. It sounds like science fiction, right? Well, today we're diving into how generative AI is being tested as a co-pilot in the incredibly high-stakes world of health economics where, every single decision has huge consequences. Let's get into it. So let's start with the central question. A brilliant new drug comes along. It could save thousands of lives, but it costs a fortune. How do healthcare systems, the ones we all rely on, decide if it's actually worth the money? Could an AI really make that kind of judgment call? It's a massive question that organizations like the UK's National Institute for Health and Care Excellence, or NICE, have to wrestle with every single day. So the way they do this is through a process called health economic evaluation. You can think of it as this super deep, data-heavy analysis that weighs all the benefits of a new treatment against all of its costs. And let me tell you, this is a colossal undertaking. It's incredibly resource-intensive, and it takes whole teams of experts a ton of time to get it right. And this, of course, is where GenAI comes into the picture. The promise is enormous. I mean, what if AI could help automate these crazy complex evaluations, make them faster, more efficient, maybe even more accurate? But, that's the promise. The real question is, what's the reality when the rubber meets the road? Well, to find out, the HTA Innovation Lab at NICE didn't just sit around and theorize about it. Nope, they actually rolled up their sleeves and ran a series of real-world experiments. They set up 3 totally distinct projects to test exactly what GenAI can, and, just as importantly, what it can't do in this environment. So, let's see what they discovered. All right, our first case study. Let's call this one the AI translator. The task here was to take a really complex health economic model for an Alzheimer's drug, which was originally built for the US, and then completely adapt it for the UK's healthcare system. This is something that happens all the time, and it's a super time-consuming job for health economists. And what's so interesting here is that this is not a simple copy and paste job, not even close. You have to change pretty much everything, from economic stuff like discount rates to mortality data, healthcare costs, even how the disease itself progresses in a different population. The AI's job was to hunt down and swap out all of these US parameters for their UK equivalents. The whole process was really methodical. First, the AI had to replicate the original US model just to prove it understood the basic structure. Then, it went on a data hunt, identifying all the right UK-specific sources. And finally, it automatically plugged all of that new information into the model to spit out a UK-specific result. And here is what it found. The AI calculated that the drug would cost somewhere between £190,000 and £250,000 for every quality-adjusted life year it adds. That metric, often just called a QLE, is the gold standard for measuring a treatment's value. Now, that number was actually way higher than anyone expected, which was a huge red flag to the researchers that, okay, something more complicated is going on here that needs a human to really dig into. So the big takeaway from this first case is pretty clear. The AI was fantastic at the grunt work. I mean, finding and summarizing data, which saves an unbelievable amount of time. But, and this is a big but, when it came to making the final judgment call on which data was the right data to use, you absolutely needed a human expert in the driver's seat to guide the whole process. Okay, let's move on to case number 2, because this is where it gets even more interesting. Here, the AI was given a new role, the auditor. Its job was to check a complex model for an asthma treatment for any logical flaws or math errors. This is a process called model validation, and it is absolutely critical for making sure the results are believable. So the researchers basically handed the AI a validation checklist, pretty much the same one a human would use. This involves running a bunch of stress tests on the model. Like, for instance, what happens if you set all the costs to 0? Well, the final cost should be 0, right? If it's not, you've got a bug somewhere. The AI was programmed to just systematically run through all of these checks. Their results came back, and at first glance, they looked completely identical. A human quality assurance expert ran the tests and found the model passed 12 out of 14 checks. The AI? It also found the model passed 12 out of 14 checks. A perfect match, right? Well, not quite. This is where the story gets really wild, because while they both agreed on the number of past checks, they actually disagreed on which specific checks had failed. And it turns out the AI was right. This just perfectly shows the AI's power. The AI failed a test that the human expert had accidentally marked as passed, and it turned out there was this tiny, subtle human error in how the model was set up that the human reviewer just missed, but the AI's cold, hard logic, it caught it instantly. Once they fixed that little human mistake, the AI's test passed. I mean, that's just incredible. All right, on to the final and, honestly, the most ambitious test of all, the AI Builder. So here, the challenge wasn't just to adapt a model or check a model, but to actually build one from the ground up, based on nothing more than a simple blueprint. The AI was given just two things: a Word document that kind of sketched out the model's concept, and an Excel file with all the data. This is designed to mimic a really common real-world workflow, where an economist first draws up the plan before they start building the code. So the question was, could the AI actually turn that plan into a working model? The answer was a massive yes. And the speed was just staggering. The GenAI tool built the entire complex model, we're talking over 1,500 lines of R code, in just 24 minutes. 24 minutes! That is a task that would take a human expert days, maybe even weeks to complete. But, and this is a really big but, here's the critical trade-off. While the AI was unbelievably fast, its results were off from the original human-built model by as much as 37%. Now, in this specific case, the ultimate conclusion on cost-effectiveness didn't change, but a deviation that big is a major, major red flag. So what happened? Well, the AI didn't make dumb coding mistakes or typos. The problem was much deeper and much more, well, human. When the AI interpreted the high-level blueprint, it made different underlying assumptions than a person would. It just lacked that implicit knowledge and context that a human economist has. This is the key lesson. Even if the code is technically perfect, if the logic is built on the wrong assumptions, your results can be way, way off. It just hammers home, again, the non-negotiable need for expert human review. So, after these three really fascinating experiments, what's the final verdict? What did we actually learn about the role of GenAI in this incredibly important field? It really all comes down to this. As a translator, the AI is a super fast assistant, but it needs a human to point it down the right path. As an auditor, it's a shockingly accurate and unbiased checker that can even catch our own mistakes. And as a builder, it's a lightning-fast architect, but every single assumption it makes has to be verified by a human expert. And all of this leads right to the core conclusion from the NICE report itself, which I think just says it all perfectly. AI methods should augment human involvement, not replace it. It's not about taking humans out of the loop. It's about giving them this incredibly powerful new tool. So, we kind of end where we began. The evidence is clear. AI can be an amazing co-pilot. It's fast, it's accurate, it's tireless. But these experiments also make it crystal clear that for now, and probably for the foreseeable future, the complex judgments, the critical assumptions, and the ultimate accountability, that all has to stay in the hands of the human pilot. So the real question isn't if we should use AI anymore, it's how we can best train humans and AI to fly together. Thanks for joining us for this explainer.